Hi, I'm Eric Stewart, and I want to thank you for listening to this digital presentation of progress and future goals for bedrock mapping in southwestern Wisconsin. I'm going to review current bedrock mapping going on in Grant County in the southwestern part of the state and propose new bedrock mapping in Lafayette County just to the east of Grant County. All this work that I'll talk about is, of course, collaborative and includes help and ideas from a large number of people. Steve Mall, a GIS specialist at the survey, and Sarah Bremer, a geologist at the survey, are large contributors to the field mapping effort, and many of the ideas and work that I'll talk about comes from them. All right, I'm going to start by reviewing ongoing state map supported mapping in Grant County, which we're doing right now, which we're working on right now. One of the goals of the STATEMAP geologic mapping program is to establish the geologic framework of areas determined to be vital to the economic, social, or scientific welfare of the U.S. And we proposed to do bedrock mapping in Grant County last year because geologic mapping could potentially help understand and assess groundwater quality issues in the area, which falls under the social or societal welfare portion of the STATEMAP goals. Groundwater quality issues were recognized in Grant County by the Southwest Wisconsin Groundwater and Geology Study, or SWIG, which includes hydrogeologists at the Wisconsin Survey as well as collaborators from the USGS and elsewhere. And as part of that study, they detected coliform bacteria and or high elevated values of nitrates in a large percentage of private wells in the area in southwestern Wisconsin. And so we propose to map two 7-minute quadrangles at 1 to 24,000 scale, in part because of the relatively thin hydrostratigraphic units in the area, and also to identify any subtle folds or structures in the area. We also wanted to compile hydrogeologic observations that might help assess contaminant susceptibility. The reason why we proposed only two quadrangles was because most of the southern part of the county has already been mapped at 1 to 24,000 scale, as seen in this figure here. So all of the dark green areas are 7-minute quads that have been mapped by the USGS in the past. For STATEMAP, we proposed the two quadrangles kind of in the middle here in light, kind of light blue, the Mount Hope and Fenimore quadrangles. So these two are in addition to internally funded mapping at the Wisconsin Survey that's also going on right now, and that's these four quadrangles in kind of a lightish green color, the Bagley, Bloomington, Long Hollow, and Castle Rock quadrangles. So in total, with the USGS maps already done, with ongoing internally funded maps, and with STATEMAP supported mapping, we should have the bulk of the county mapped at 1 to 24,000 scale, which we're excited about. We began mapping the STATEMAP supported quadrangles just a couple months ago, so we don't have a whole lot to talk about yet on those quadrangles, but I can talk about some of the 1 to 24,000 scale mapping we completed last fall that was internally funded by the survey. And the reason to talk about that is because the STATEMAP funded maps are going to follow a pretty similar project plan and have similar goals and probably produce similar products. So the area that we've completed at least the line work in is in the northern part of the county. So the Long Hollow and Castle Rock quadrangles up here in dark blue. And so the line work is done and the map is in the cartography stage right now. So pretty soon we'll have polygons with colors. But the map down here in the bottom shows some of the line work and the level of detail we can get at the 1 to 24,000 scale. In addition to the actual maps we're working on, in part based on feedback from last year's meeting, we're also working on rasters of all the major geologic contacts. So these are on the left are two of those surfaces, the base of the Prairie Sheen group and the basis of the St. Peter Formation. And for reference, in the stratigraphy of Wisconsin, the base of the Prairie Sheen group is at the Cambrian-Ordovician boundary, and the St. Peter is immediately above the Prairie Sheen group. So these are structure contour maps, and what they show is how that surface, the base of the Prairie Sheen group on the bottom and the St. Peter on the top, how it changes in space. So the warmer colors are highs, the cooler colors are lows. And so in the case of the base of the Prairie Sheen group, you can see that it's been deformed into a series of gentle low amplitude anticlines and synclines, amplitudes in the range of 100 to 200 feet, so pretty small. The base of the St. Peter Formation is an unconformity, and the underlying Périodicine group in that area is karsted, heavily karsted, and so the upper map is showing that unconformable surface, and it's quite a complicated surface, but it does resemble a karsted area. In addition to using the geologic maps and the rasters of different geologic contacts to provide a geologic framework for the area, we're also trying to identify hydrogeologically useful features that might be useful in assessing in groundwater contaminant studies. So, and that was the original motivation for the work in the area. So the data here, we're looking at spring and seep data, and it comes from the two quadrangles that we finished mapping already, the Long Hollow and Castle Rock quadrangles in the northern part of the county. And the histogram on the top is looking at springs and seeps relative to the distance in kilometers from the nearest fold axis, the nearest structure basically. The solid colors are seeps, and the diagonal columns are springs. And so here it seems there's some sort of a concentration of springs and seeps near map folds, though the data set is relatively small, and most of the observations come from the Périodicine group. So the colors here are related to the unit in which it was observed, so the grays are the Périodicine. And I will mention that this year I've spent far more time higher in the stratigraphic section, and the springs there are almost all stratigraphically controlled and seem to be concentrated in the Decorah Formation, which you'd expect in the area. The histogram on the bottom is looking at any kind of potential stratigraphic control on springs and seeps in the same area. So here it's plotted relative to the base of the Périodicine group. So the 0 point is the base of the Périodicine. Here we're looking up the section in the Périodicine, where are the springs and where are the seeps. And there might be a slight concentration of seeps around 150 feet above the base of the unit, but not a strong concentration. We also use LiDAR to identify probable sinkholes. Here we're looking at plots from the two 7-minute quadrangles completed, but we're planning on doing the same for the STATEMAP funded quadrangles. The histogram on the top is looking at sinkholes plotted relative to the base of the Périodicine group, which is dominantly a carbonate. Most of the data points come from the Périodicine, which is the gray color here. So the base of the Périodicine is at 0, and so we're looking at sinkholes as you go up the section. So as you can see, there isn't much stratigraphic control and sinkhole distribution. The plot on the bottom, however, now down here we're looking at sinkholes plotted relative to the St. Peter Périodicine contact, which is right here, so the 0 point. So this was a contact, as I mentioned earlier, it's an old unconformable contact marked by karsting. And that contact moves up and down the Périodicine surface. So here we're normalizing it to that contact. And when you do that and you plot, when you plot sinkholes relative to this contact, most of the sinkholes are found immediately below the contact. So which suggests this is an important contact for sinkholes. Finally, as I said earlier, all the 1 to 24,000 scale maps and associated data are being compiled into a 1 to 100,000 scale Bedrock geologic map and report. And that process has already started. The map on the bottom left, the Bedrock geologic map, is the first pass geologic map for the Grant County that Steve Mall put together. And as we go forward, we'll continue to edit that surface, include more field data, and by next summer, hopefully we'll have that done. On the right, this is the base Platteville surface for the county, and so we're going to include rasters of all the major surfaces in with the report. For fiscal year 2021, we're proposing to move to Lafayette County, just to the east of Grant County. So Lafayette County is right here, just to the east of Grant County right here. So we're in the southwestern part of the state. And we're proposing to continue this approach of targeted 1 to 24,000 scale mapping and then upon completion to compile into a 1 to 100,000 scale map, bedrock map at the end of the project. So the reason why we're proposing Lafayette County is because Lafayette County was also part of the Southwest Wisconsin Groundwater and Geology study, the SWIG study, that found elevated bacteria and nitrates in many wells. So moving to Lafayette County will allow us to continue to work on the geologic framework of an area with a groundwater problem, and so it has societal relevance. We're proposing to map the bedrock geology of Lafayette County over 2 years. Much like Grant County, about half of Lafayette has already been mapped at 1 to 24,000 scale. So on the map, all the greens, dark greens, are already mapped 1 to 24,000 scale, 7-minute quads by the USGS. So we're proposing to map 3 7-minute quads as part of next year's STATEMAP grant. The Apple River, Darlington, and Waldwick quads, it's kind of here in the center part of the county, and then 3 more the following year, so fiscal year 2022. So the 1 to 24,000 scale mapping would include both bedrock and quaternary, and so it would be done in conjunction with Eric Carson's quaternary STATEMAP project in the area. And then again, at the end of the 2-year project, we'd compile into a 1 to 100,000 scale map with rasters of the major geologic contacts.